Welcome back. We're back again with Fresno State Physics Outreach. We have Don Williams, and he also brought along a colleague of his. We have Professor Carl Rundy. And you guys are here. Okay, so we always talk about your college students. We had UV on. She was showing me exactly what she learns in your class, how she teaches science. She can even teach me science. But you guys actually go out to high schools to recruit people to come take your classes at Fresno State. So what's that process like? Why do you guys do that?
Carl, tell them, what are we looking for?
Well, we're looking for some really talented, interested students who are interested in physics and interested in math. So if you like mathematics, then you should come talk to us. And
because
we
you
have a lot of work for you.
Light things on fire, and you get to do experiments.
Well, we also do a lot of theoretical and mathematical work.
See, that's what
Carl, go ahead.
Carl does a little bit more of that. He teaches a lot of basic mechanics and electromagnetism, and you've got to use a lot of theory of that at start at first too. Of course, you have demonstration with it, like we're going to show you in a little while.
That's always fun.
But you know how it is, Emily. We've got students all around this valley that are talented as hell.
And you need sort of that brain that can really understand numbers and math and calculus. We were talking about that you guys always find great potential in high school calculus classrooms.
That's what we're looking for.
We do.
Yeah.
We do.
Why do you think that is?
Because those are students, they're ambitious and talented and they like math. And so we want them to like it and come to us because we can help them on their way. And
sometimes it's hard to know how you can apply that to another science. You know, you could think I'm really good at math, I must major in math. But that doesn't necessarily have to be the case. Maybe I'm really good at math and I major in physics, or I major in another science, or I try out physics.
Engineering, meteorology. Weren't we just talking about meteorology?
We were.
Yeah, exactly.
I love meteorology. I love meteorology.
That's right.
But then AJ Fox told me I had to take a calculus class too.
And some physics classes.
Yeah. To get a master's in that.
Like
but I'm one of your best students, right?
But you're right. But to do a lot of higher order stuff, we have to have calculus.
Yes.
So it's one thing we use it as a tool, Emily. It's a very powerful tool.
Right.
It's actually a beautiful thing when you understand it. But like you said, really, a lot of the math classes just teach calculus. We show them where you can use it.
How you can use it.
Yes.
And it's so great, you know, when I teach and I meet kids who have already been editing video in high school or editing video in junior high, it's always so great because they have such a great foundation. They can really go and go a lot of places.
Exactly.
Be some of your star students.
Exactly.
All right, Professor Rundy, of course, you got to have an experiment if you come here with Don Williams. What are you showing us today?
Well, we are doing thermal physics these days. We just saw the torch melt the penny. And I'm going to turn a stick of butter into a candle.
Okay, now I was telling you that I've seen this done at the restaurant at the Piccadilly Inn. They do a butter candle and they give you a whole bunch of bread and then you dip the bread in the butter.
In the butter, huh?
This is better, we hope.
Okay,
we hope this is better.
Regular sweet cream unsalted butter.
And I have to tell people to use cotton string for the wick.
Okay, cotton string.
If you use nylon, you're going to regret it. Okay?
What would happen if we use nylon?
It will melt on the spot.
Oh, okay.
Yep.
So we just have to press it into the butter like this.
Yes.
Got that? And we want to make it look good.
So he's got it about halfway in,
a little out there.
Okay.
And you know, butter is just fuel. In fact,
it's fat, right?
If you were to read the label here, first thing it says is
calories.
Calories.
How many calories is that?
100 for 1 tablespoon
of for only 1 tablespoon.
Butter.
So a calorie is a measure of heat or thermal energy, if you want to be precise. Now we're just going to fire this thing up.
Oh, this is the most romantic.
Isn't it though? Well, see, you could form it into anything you want to, huh?
Sure.
Now we're talking.
All right, there it goes. The cotton wick is burning.
Okay, now's the crucial moment. Is it going to go out or stay lit?
When it gets down,
looks like it's staying lit. Okay.
It does.
Now it's really burning out.
I want to hold my breath.
If there's 100 calories in it, how much is in that whole stick of butter?
800 calories.
That's nothing.
That's nothing for the likes of us.
Exactly.
And yeah, I can see that's a very nice looking candle. Look at the image over there. Yeah, right.
And so
there we have it.
That butter will just continue to burn.
And the calories are what I'm feeling in my hand right now.
Oh, so when I go to the gym and my watch tells me I've burned such and such calories.
That's right.
It's because calories are heat. All right. We always learn something when you guys come here. Thank you so much.
Thanks
Everybody
for having
else,
us.
stay with us because we've got more Central Valley Today when we come back.